The fourth installation on the Solar 2007 Tour of Large Professional Solar Installations is the joint training facility for the contractors in IBEW Local 11. The union and the contractors are very serious that the future of their union is deeply bound up in green jobs. They don't see a problem between jobs and the environment. They see jobs and the environment. So they're very serious about training and gearing up for solar and for doing large professional solar installations, for being a part of the future of a greener California with a very vastly improved and very vastly expanded, well-paid and talented world-class workforce.
First of all, I want to thank all of you for participating in this tour.
Three semesters, so to speak. Every apprentice goes 2 of those 3 semesters. So basic computer skills, but anymore, most of our apprentices coming in know more about computers than any of the staff or instructors do. So we don't have a call for that very much. However, this lab is used mostly for, as you saw, the motor control is kind of the analog version over there, but a lot of motor control, especially in process plants, whether it be refineries, food service, just about any process plant is going to digital controls.
Solar system on top of the Union Training Center, the Joint Contractor Union Training Center. You can see it's pretty huge. It's 500 kilowatts. These are Kyocera panels. Picture of that. These 1, 2, 3, 4, 5, 6, 7, 8 gigantic rows, all canted at about a 30-degree angle, 23-degree angle, and a total capacity of almost 500 kilowatts.
The system is among the highest producing in the world. There's a number of reasons for that. First of all, the way it's positioned, we took into account not just the latitude, but also temperature profile and smog profile for the year in Los Angeles here. The panels will stay very cool in this type of structure because you can see there's air around all 4 sides of the frame. They're up off the roof, and we've actually tested that, and the panel is about 25 degrees C cooler on a real hot day from being up on the frame versus being flat on the roof. We also use several electrical techniques which help to provide very low losses. In fact, DC losses in this system are about 0.2%. The first thing we do is the topography was basically designed on a computer to minimize the length of the wiring down to the inverter. So the buses and everything are kind of strategically placed. The wires upsized about 3 times. So you take the electrical code requirement and go three levels up from there in terms of sizing, and you'll come to the type of wire we're using. For example, the last 2 rows here are connected with a 600 kcm bus, and a wire about like that diameter. And that can basically handle about 600 amps, 650 amps, and we have about 250 amps going through it. So as a result, very low losses. We also do not use the quick connects. We cut those and go into standard oversized electrical wiring. That takes place inside the conduit, which also assists in keeping the wires cooler, which further results in some loss, some improvement in DC loss.
Here's the system from the ground at the training facility for the IBEW Local 11. You can see it really looks like a beautiful system. From underneath it, it's just almost like a schooling. It's like a paradigm system. It's a beautifully constructed, very neat, orderly system.